Wonderful. Thank you, Jeremy, for the wonderful introduction. So the paper I'm going to talk about, it's on strategic use of trust. It actually originated when I was doing a postdoc in Mannheim, and it's a common project with Rado Vadovic, and then we also took Steve Tucker on board because he had some very interesting ideas of how we could pitch the project. Interesting thing about Rado Vadovic, maybe I'll introduce him as well. We're longtime friends. We went to high school together, used to sit in the same desk. Then we studied later on in Arizona. We got our PhD. And by the time when we finished the PhD, I got my short postdoc in Mannheim, and Rado got his in Heidelberg about 10 minutes apart. And at that stage, it looked really, really suspicious. So the only good thing about it was that we were both married. Because people could get... Well, anyways. I'm going to start talking about trust, what trust is, because trust really is, when you think about it, it's kind of a vague term, right? And we economists, we like to specify what we're going to talk about. So what this trust is. So in general, when you think about it, sort of some sort of phenomenon, right, that is present in many social and economic activities. And in certain scenarios, the presence of this trust allows the agents to achieve mutually better outcomes. Okay, and the examples like that, these could be trade transactions between two parties. It could be an investor and an entrepreneur. It could be employer and an employee. Potentially in these social interactions, think about husband and wife or friends. The economics literature mostly defines trust, or rather trusting action, and the most common interpretation is along the lines that we cite from Cox, who's going to be here later this year. And so James, in his 2000 paper, says that an agent undertakes an action that exhibits trust if this chosen action creates a monetary gain that could be shared with another agent, and at the same time exposes this first agent to the risk of a loss of utility or monetary loss if the other agent defects and appropriates too much of all of the monetary gain. Okay, so obviously, so we have these two things that are important. One is creating a monetary gain, and the second one, the risk of loss of utility. Now, there's a huge body of economic literature that is, explores various aspects of trusts, and a lot of these papers try to explain different things about trust, and also the deviations from this conventional game theoretic prediction, where everybody's just self-regarding. Sort of one of the seminal papers in this area was a 1995 Barry Dickhout and McCabe experiment, where they introduced this investment, or sometimes called a trust game, and I'm gonna get back to it. So I'll explain exactly what we have in mind. However, despite this huge body of literature on trust, there is no uniformly accepted theory what trust is and how it originates. There are several economic models that have been proposed that try to explain trust as a product of rational behavior. For example, Falk and Fischbacher have a reciprocity story where they say, well, if we make an assumption that the second person is reciprocal, that means returns a favor with a favor, in general terms, then a trust is a rational thing, because you can rely on the fact that the second person, if you're nice to the second guy, then he's going to be nice back. Another quite influential study was done by Battigalli and Duffenberg in 2007. This model, hinges on guilt aversion, where the main assumption is that the second guy is guilt averse. What does it mean that he's guilt averse? It means that he doesn't like to let other people down. That is, he tries to behave according to his belief about what are the expectations of the other people towards him. Okay. Similarly, Slivka in 2007 has a conformist type of story where there are three types of people. There are the good types and the bad types, and the conformist actually can decide what if there are more good types, then the conformist is actually going to change and act trustingly. Okay. These are sort of like the three most prominent models, but there are some other ones as well. Now, what is our departure from the literature? So our view of trust is actually a little bit different. We're trying to pitch it as something that is, as a belief rather than an action, right? So the previous literature was talking about trusting action. We're going to be talking about trust being a belief. So in this case, our trust is going to be represented by the first mover's belief in the second mover returning a fair share. Okay, now a fair share, again, you might think that it's a vague term. Just at this moment, just think about something sort of generic as fair. We're not, our argument is not going to actually hinge on what this fair means. So then in this slide, the first mover's action is going to be a commitment device that's going to signal this belief. Okay, so that's going to signal this trust. And so in our view, player A's belief in a fair response from player B and her level of trust are going to be innately related. Okay? And then the amount of that is going to be sent, right, or invested by player A will very likely correlate with this belief that that player A has. But we're not going to assume that ex ante. We simply consider the amount sent by player A to be a costly message, right, or a signal to player B. That's why it's a commitment device. And what we're going to be studying is going to be the relationship between player A's belief and the amount sent to the second player. So if this is, if we assume this structure, then here's our conjecture. If trustee, right, can ascertain the truster's level of trust from her action and in turn respond to it positively, right, that means reward this trust, then truster may want to manipulate her level of commitment to induce more favorable response. Seamus.
Just so I can understand your pronouns here, is the trustor always female and trustee always male?
No, actually, I think we just had everybody her in this thing. So so the trust. So the first. Oops, I always keep pressing this. So the first mover may want to manipulate the amount sent, the investment, in order to induce more favorable outcome.
Why does the trustee send anything back? Any one of the stories?
Any one of the stories, exactly, right? So this actually is something that we haven't found in the literature, and because most of the literature hinges on the fact that, or an assumption that trust is something inherent, right? I mean, something people just are born and are being nice, and it could be also evolutionary or something like that. However, here we're going to actually say that this trust could be also strategic, right? I mean, the economic agents can behave in such a way that they're just going to try to maximize their own profit. Okay. Now, we're going to test this conjecture by comparing the behavior in a trust game.
Why does the trustee send anything back if they're just maximizing?
The first guy, the truster, the first, right?
The second guy is just crazy.
Yeah.
Okay.
Crazy.
I understand
Yeah.
very well. That's fine.
And so we're going to test it, right, by comparing the behavior in a trust game that is going to be played sequentially and simultaneously. Okay.
Point of clarification. I'm wondering if the person or the agent who might be manipulated ever finds out in this game that he or she is being manipulated, and that knowledge is known, would that affect the level of trust in the game? Or you don't deal with that?
We actually didn't deal with that. We considered that, we actually did consider it, and at the end, if I have enough of time, we have a theoretical example at the end. I also put it at the end of the slides that I might just walk you through it, and we can actually show that even in equilibrium even if the other guy knows what the beliefs are, then this is going to be just an equilibrium. This is what we could observe.
You use the word manipulate suggests that there's a counterexample that you can actually refute. So the word, I mean, you can think of a strategy which you might call manipulation, which might actually be the best response in a sequential game. Because
Right.
if I was trying to establish trust with someone, then my first response might be to give them, an excess reward in the first instance to try and buy that trust. But over the
Right.
whole period of the game, if I can continue that through, it might be the best response. But you're calling that potentially a manipulation.
Right. So what we're gonna we're gonna just consider a one-shot game here
Okay.
in this scenario
Just
to
a
show
bit
that.
of trust.
To just think about trust between two parties that don't know each other, right? It's just one of sort of transaction, and this is actually we're also thinking about looking at.
Interesting that you motivated with marriage then.
That's why I came.
Repeated also could be, done with a repeated play, although most of the literature is just looking at one-shot interactions over here. Okay, so that's why we're just sticking with a framework. So when this commitment, right, or signal by the first guy, first player is going to be observable, then the ability to signal is going to create a stronger positive relationship between trust. Right, is going to be presented in our case by the belief mu and her action than when it is not observable. And this is going to be reinforced by a positive and increasing response by the trustee. Okay? So we have these examples. So I mean, the reason why we're doing an experiment is because in the real life, it's often really, really hard to find something where you would have this thing just pure. Okay, and usually the examples that we're also going to provide are just going to be confounded with possible other effects, right? But here are several of them in which this trust signaling could be possible, right? So in many institutions, people actually transact sequentially, and the success of this one-shot interaction is often going to rely on the first mover having trust in the second mover. Okay? So an example could be an internet auction. The final price that is going to be paid by the seller, but by the buyer, could actually signal trust in seller's credibility, right? So I wouldn't be willing to put a high price on the item if I did not believe that the seller is going to deliver it or that the quality is low. Okay. There are other possible explanations, but this is feasible. In labor market, right, the size of a salary might signal trust in the ability and diligence of the worker. Again, if I did not believe that the worker is going to work hard, I probably wouldn't be willing to pay high wage. Or another one, co-payment requirement might signal the bank's trust, or lack of rather, in the entrepreneur's ability to pay back the loan. So the strategic use of trust, or trust signaling conjecture, could be used. We could use different models to derive it. So, for example, let's look at the guilt aversion in more detail. So this is 2007 and 2008, two papers by Battigalli and Dufferberg. In this game, under this assumption, you would have two players. The first player decides to commit or signal express this signal his trust, and the behavior actually represents his beliefs. Why? Because so the second guy, if he's guilt averse, he will want to behave in a way that is going to be consistent with the first mover's expectations. Right? So really what it does is the second mover creates higher order belief, second order belief, right? So I create a belief about what you expect me to do. Then if I, as a first mover, send you higher amount, higher investment, it signals that I have higher expectations. Why? Because if I hadn't, then, if I do, then there's more for me to lose. Eric?
Has anybody ever tried to run an experiment testing between the two theories?
between the guilt aversion reciprocity. In where is it? Chernes and Duffenberg, there is an example where these two give different predictions. Guilt aversion comes on the top on that one.
Imagine a way of doing it without oxytocin.
I'm not sure. I think
Give people a dose of oxytocin to demonstrate more trust. Guilt aversion, you feel bad about screwing over the guy who ended up having to give more than he wanted to because of the drug. On reciprocity, there's no reciprocity established. He was forced to give
could be.
more than the drug.
I actually don't. I'm not a big fan of this neuroeconomic stuff. And I don't. So I actually don't believe that the oxytocin just increases the trust itself. It probably affects something else, and then the behavior is more trusting, right? So I don't think that would be actually a clean test. But that's just my sort of gut reaction to that. In the reciprocity, under the reciprocity assumption, what you have is what's important is the perception of behavior. So the higher investment by player A, the higher or the bigger perception of kindness we have by player number two. Okay, so if this is the case, then the truster might have stronger incentives to invest when her action is observed. Okay, why? Because just by investing more, I'm inducing a stronger reply based on the reciprocal preferences. Okay, and these reciprocal preferences come from the fact, how do I perceive your actions? And hence, since I'm giving out more to you, that means that I'm just kinder because I'm foregoing some sure payoff in my case, and I'm actually creating a gain. Okay, and I mean, all these models have some slight differences, but pretty much each one of them amounts to sort of this argument.
I know at least one couple in each box. Okay.
The vehicle of our study is going to be this modified trust game. Okay, so I sort of described it before, but now this is the representation. So we have two players: player A, the truster; player B, the trustee. Player A has $10 at the beginning and can decide what amount of $10 to send. I mean, what fraction of $10 to send. Actually, in the actual experiment, we chose to do it in $1 amount, right? So it wasn't fully continuous, but this is just an easy representation. So then, after player A sends T to player B, this T is tripled by the experimenter. Okay, so this is where the monetary gain comes from. Okay, so it's somehow shows the gains from trade. Right, or an increase in efficiency due to trust, essentially. Now, then player B, the trustee, observes the tripled amount and decides whether to send 0 back to player A, to the truster. In that case, the truster, player A, gets 10 minus T, what he sent, and player B keeps the tripled amount, 3T. Or the other option that he has is to send back half. If he sends back half, then player B has 10 minus T plus half of the tripled amount, and player B just keeps the tripled amount. In the experiment, this is going to be played just once. We're going to have two subjects, one being player A, the other one being player B. Player A is going to be endowed, actually I already said that, is going to be endowed with the real $10, and he's going to just send it back. All of this is a common knowledge. Okay. So now the research questions and hypotheses. Question number 1 is, do trusters strategically signal trust? So our hypothesis here is that the mean T, right, the average amount sent, conditional player A's beliefs, is greater in the sequential treatment than in simultaneous. Question number 2, do trusters benefit? Right? I mean, if you are signaling trust, is it beneficial to you? So here we're going to ask whether A's beliefs are correct. Okay, and whether players B really reward higher T, higher investment, with higher propensity of fair split. Jeremy?
Just a question on the first one. Finding that people are more trusting in the sequential one is consistent with your theory that they're doing it for strategic purposes. Is it sort of like a one-for-one, or could there be other reasons that people would give more in the sequential one that are not about strategically trying to get more out of it?
So,
how much of a jump there is between the hypothesis?
Between the hypothesis and this. So, I think the idea behind the experiment is that this strategic behavior it may not be necessarily strategic in a sense. I'm thinking, oh, if I send him higher T, then, or I would send him 5, say, but I'm going to send him 7 because I want a better response, right? It's more, I would say, it's more hidden and more subtle than that. It's just exploiting the institution in which they're interacting, and therefore the institution that allows for display of trust is going to cause people to send more.
These are all one-shot games. This is going to be one-shot
Yes.
games, right?
It's just one-shot game.
So how would the individual first player A, whatever, would that person know how the other individual in the game will respond? If you provide a certain amount of money or whatever to that other individual, you know what the payoff function is. Would that person know how much he or she might get in return in putting a certain amount of money into the pool? Would the return be low? Would that be high? Would that no?
So this is going to be a belief, right? That's going to determine, and we're going to measure beliefs. So this is going to be part of the experiment, because we're going to be interested about what is the relationship between the beliefs that they have, what we call the trust, right, and the actual amount sent. Okay, does that answer your question?
So the belief is not something which evolves? Or
No.
Evolutionary.
No, not in this case. No, this is going to be just one-shot game. You have a belief, and whatever that is. Right. But that's actually a very good question, because towards the end of my talk, I'm going to go there and I'm going to ask several questions about the evolution and updating of beliefs that I think are quite interesting in these psychological games over here.
So if it was a sequential game, not sequential, but a repeated game, then those beliefs could form over time, and that's how they...
Yes, that's one extension. The other extension is also looking at the beliefs of player number 2, right? Because player belief also has player 2 has some beliefs, some priors, but then once he observes T, then he should update these priors. Okay, but I'm going to sort of sketch it at the very end.
What I thought the original question was to what extent the players are able to compute the min and max, or the range of outcomes that could possibly transpire. That is, to try and work out whether you've got support or otherwise for your hypothesis, has to eliminate those that don't understand the nature of the game,
Right.
or act randomly, or do something else. And you might be inferring something from the observation, which is in some sense not their actions, but their inability to understand the game or whatever. So,
Yeah.
but I mean, do you question them later to find out whether they knew what the outcome could have been for different values or what they sent?
So we do several things. First one, we ask them about their beliefs, and then we observe their behavior. And the second, at the very end of the experiment, we do ask them questions about what was their strategy and why they acted that way. Okay? And I mean, most of the answers are pretty consistent, with the story that we're telling.
Is there another sort of component to H1? I was just thinking, supposing that you reject H1 and you find mean conditional beliefs are basically the same. There's got to be some information in the dispersion and variance of those belief distributions? At least that's what I would kind of think.
There's going to be
heterogeneity in the sequential game than in the simultaneous.
It's actually a very good question, and again, I think it all hinges on what the beliefs are, right? And so, hence, the beliefs are going to be affected by the institution, whether the game is played sequentially or simultaneously, right? And we cannot control for the beliefs, but we can measure them in the experiment. And then, based on that, we look at certain things. So the
hypothesis is conditional on some belief that you've kind of elicited in some way.
Yeah.
What I'm just thinking is I think there's more information in that distribution of T's than the mean. That's all. I mean, even if the means were the same, there might be something about the mean.
Let me write it down.
The theory would predict. I mean, I don't know how.
I mean, there's going to be we're going to do tests with the distributions at the end.
Because you could look at like you could look at stochastic dominance kind of things under the two things. Just look at the level of just look at the whole distribution rather than just the mean. I guess that.
Right.
Maybe
Yeah.
So you're talking about fair split, but you only let them do half.
Right. So I mean, this is sort of our interpretation, right? Because there was a reason why we chose to have it binary, and we had to implement certain split, and we said, well, let's let a half be fair split in this case, but it could be it could be different, right? I mean, there are different notions of fairness. We just had to make a choice, for design. Yeah. Right. So the second hypothesis is going to be, we're going to be testing whether there's really an increasing relationship between the T and the frequency of fair split as made by B's. And then the last one, question number 3, is regarding the efficiency, right? So does this trust signaling improve efficiency? And so in the sequential treatment, if mu, if the belief is high, then it is optimal to send high T. Okay. However, if mu is low, then it is optimal to send T equal to 0. Right? If my belief that the other guy is going to return a fair split is low, then I should just send 0, because that way I'm just maximizing my payoffs. However, we don't know what is the distribution of these mu's. Right? Thus, a priori, we can't really make a statement whether we should expect this efficiency to be higher or smaller in sequential treatment than in simultaneous. Okay? It's just going to depend on the distribution of mu's. So the third hypothesis is just that there's no difference in efficiency. What do we know? So here we're going to be measuring efficiency. Efficiency is measured by the average T, right? And so it's going to tell us that the sequential, if I reject it, right? It's just going to tell us that the efficiency in, I'll just tell the result, in the sequential is going to be significantly higher than in the simultaneous. So that means that the realized profits or monetary gains in that type of institutions were higher than in the other one.
Yeah.
And so
I know, but what do I know about trust if their hypothesis is rejected?
this is not about trust. It's just this is sort of comparison of institutions. Right? So the trust is rather over here. Over here, the trust, we're observing we're looking at commitment here, right? Whereas the trust depends on mu. So if you want to sort of go an extra step, it would mean that the mu on average should be higher than in the sequential than in the simultaneous, and if all of the above are true, then we would observe higher T's based on higher mu's. I guess. Does that answer your question? Okay. So, sort of just to summarize the experimental design, so we're going to have two treatments, right? The sequential treatment, where the player B is going to observe player A's decision prior to making his own, and this allows for trust signaling or strategic use of trust. And the other one, the simultaneous, where player B does not observe player A's decision prior to making his own, right? And hence, there's no possibility of having trust signaling,
Do
right?
you have beliefs on the B players as to the amount that would have been sent by the A players?
Yes, we hold on. No, we measured the beliefs. We measured the beliefs. We wanted to know what the beliefs of players B were regarding what the players A expected them to do.
Okay, good.
Hold a second. No, that's not. I thought you said you were measuring the belief of player A.
Yes, that's what we're focusing on. But he was asking about the other one. But we're not testing guilt aversion.
But did you measure that as well?
You just said that you are measuring.
But we are measuring those as well.
Okay, good.
Okay.
So just clarification, so SIM is basically a measure, sort of a pure measure of beliefs with regard to both parties, their beliefs in each other.
Yeah.
Like a dictator type.
Sort of, yeah. So maybe I should discuss one procedure over here, because we presented at several conferences and seminars, and people always ask about this. So I'm just going to say it up front, since all of you are already knowledgeable about experiments. So the comparing these two treatments is somewhat similar, right? So sequential and simultaneous is somewhat similar to comparison of sequential play or direct elicitation method with the strategy method. So the strategy method is when the players have to write down the whole strategy, right? So for especially for player B in this case, it would be, what would you do? Would you send 0 or half if t was equal to 0, 1, 2 for all of them, okay? And the thing is, it often yields similar results as in these studies, but then in certain environments, right, the quality of results can be reversed by changing the response elicitation method. There's another one, Kerry, who was here about a month ago, who did one with Jim. We didn't. We just used the direct elicitation method for two reasons. One is, I believe that the trust is hot treatment, right? So a hot treatment is something where the moment when you learn something really matters, okay? And the cold one would be, maybe let me give you an example. How would you behave if you were sitting, on Sunday morning reading a newspaper on your patio and drinking coffee, and you were thinking about how would you behave if you were driving to work on Monday morning and there was during the rush hour and somebody would cut you off, okay? And the hard response is, you're actually in the morning, you're tired, you're sleepy, you don't have your coffee, you're cold, you're driving and somebody really cuts you off, and you're late, right? And somebody cuts you off, right? And there's a, in here and here, these guys actually documented that this hard response matters. So that's why we chose to do it this way. The second reason is also that it wouldn't be possible otherwise. And that is, once you're, how else would you ask for the simultaneous treatment? There wouldn't be any difference, right, between our treatments, because if you would use the strategy method for asking, how would you send 0 or half if I gave you 0, 1, 2, 3, etc., right? Whereas in the simultaneous, it'd have to be the same thing, right? So you couldn't do it. So we did it by direct elicitation method. Okay. Discussion of the experimental design. Stephen, did you have a question? Oh. The experiment focuses on really on the behavior of player A. Okay, so because we are interested in the relationship between player A's belief that represents the trust and the amount sent, the commitment, right? And thus we have a rich action space over here, because there might be not only the difference whether there is trust or not, just like in a binary type of game, but it could be what level of trust do we observe, right? And so hence, this way we are more likely to be able to capture these subtle differences in trust. On the other hand, players B have only binary action space. Okay. Now, again, there are several reasons for that, and the first one so the action space determines player A's beliefs, right? They're going to be salient. They're going to be elicited in a salient way, and it was very important for us that this decision is simple, right? And why? Because if players B decision is simple, hence the belief of player A is going to be simple. Okay, and thus it's just going to allow, more precise measurement. Also, this way it is comparable across treatments, right? Because we have stated the actions of player B as fraction, right? Because if you would take the standard trust game as over here, for example, well, maybe not draw it as continuous. Suppose if I send you $10, right? So that means over here you're going to get 30. So now you have 30 different, actually 31 different ways of how to split this money, right? On the other hand, if I send you 9, then you're going to have only 28 ways of how to split it. Hence, it's important to keep these sub-games constant, right? Because in the simultaneous treatment, they have to choose without knowing in which sub-game they are. Okay?
Do that by letting them return a
Proportion, right. And so we have 0 and 50%, 0 or half in this case.
Is there, okay, you got a binary thing, but you chose sort of half. Is there any, I don't know, stuff from the other experiments which can give you, I mean, supposing you're half, everybody would like to give just a little bit, just kind of tiny little bit, just to kind of be a nice guy, a little bit reciprocal, a little bit, not to give the verse, but they really only can choose between 0 and a half, so
yeah.
0. And is there some way that the choice of the half could be constructed experimentally, or maybe like if you went from 2 to 3, so you've got, okay, none, there's 0, that's the bottom
right.
end, and then there's, well, there's a little bit, and then 50-50.
Yeah. So there's always, that's always a problem, right, with design, because you have to make a choice about what to do, and it's possible that, our choice is going to swing behavior one way or the other. Okay, and yes, we were thinking about it, but then at the end, first of all, we wanted to do something that is going to be very, very simple, so we wanted to have it binary. And secondly, there's quite a large evidence from other trust games that one of the focal points is to return a half. The other focal point is to return a half of the created gain.
Just thinking about if you'd added one node, you might get a way of distinguishing between guilt aversion and reciprocity again, where you'd have 0, half, or an amount that just leaves the person who sent money a tiny bit better off than had he sent none, but all the rest of the surplus you get to keep.
Then my C. Then my C.
You return what he gave you plus epsilon. He's not made worse off by having given you money, so guilt aversion is thrown out. If you're reciprocal, you go to the half. If you're guilt averse.
Right. It's possible. We were, about certain things, we were also thinking ex post after we ran an experiment. And we just decided we're just not going to do anything else because that wasn't sort of the story we were telling, trying to do a horse race between guilt aversion and reciprocity. Andrea.
Would there be somebody by letting the fair share vary between the final payoff would be equal? So there would be like total burden instead of margin burden?
It would always be binary. It has some positive things that I can think of. Whether there would be a value added over, for this type of environment where we're measuring, I think we can achieve pretty much everything with this environment as well. But yeah, that's interesting. Thanks.
Are you okay with this?
Oh, absolutely. Yeah. I love questions.
Okay. Well, the other reason that I think that, so you haven't talked anything about eliciting beliefs yet. And one of the advantages of going beyond the binary space is like even if you have one more node, you've got to have some sort of consistency check on people's beliefs. And the other thing is you've got to get Glenn Hower's paper because he's given this 3 or 4 times now to NYU in England stuff. But we've got a little modular plugin for belief elicitation. And the idea is that, see, supposing you had 0, this guy's going to give me 0, or he's going to give me a little bit, or something.
Right.
Something like that.
Yeah.
And then you sort of think, well, what's the chances, what I want to elicit his belief about all or none, and then given that he's giving me some, is it going to be large or small? And so you can use those two questions to kind of tease out, is this guy, does he really understand the belief question? Are there beliefs in any sense? Is it picking up beliefs or some kind of magic number we don't know about? But that might be able to tie those two together. I know because Glenn, in our stuff, he is kind of pretty critical of
Duvenberg, yeah.
just his way of eliciting beliefs. But we're trying to design something so you guys could just plug it into your experiment and like as a little module to elicit the beliefs.
Oh, cool. I definitely want to take a look at it.
Yeah, okay, do that.
Are there any other questions? All right. So, procedures. The experiment consisted of 8 sessions conducted in March of 2007. So this was right after I got here in that room over there and that room over there. Total, we had 155 subjects. It was done across subjects with across subjects design. That means that each subject participated only in one treatment. Okay? There were 4 sessions in each treatment. On average, session lasted about 15 minutes, including initial instructional period and a payment of subjects. And the students earned on average 18.85 New Zealand dollars. So the experiment was hand run. So the way it took place, subjects would come into the room. The room was separated into 2 parts. There were desks on one side of the room and facing the wall, and then desks on the other side facing the wall. They could take any place they wanted. Once they sat down, we would flip a coin to decide which side was going to be players A and which side is going to be players B. They were randomly, so this was a random assignment. Now, they were anonymously paired with each other. So we knew who was paired with whom, but the subjects, of course, didn't. It was run under the single blind social distance protocol. So that means that we knew the decisions and the identities of each subject, but they didn't know the identities of each other. Right? At the end, we did a questionnaire study, right, that asked for decision rules and understanding and demographics. So the decision sheet. In the sequential treatment, and I'm sort of going backwards, I'm going to start with task 2 because this sort of explains the game. It said whether you were player A or player B. This was your ID number, right? So this is how we knew who was paired with whom. In the decision sheet, we would remind them what the game was like, right? The player A begins with $10, player B begins with 0. Each dollar that player A gives to player B is multiplied by 3 by the experimenter. Then the decisions of both players will be made sequentially, right? Because this is in the sequential treatment, simultaneously in the simultaneous. Therefore, player B will know how much player A has transferred to player B before player B makes their decision of whether to return half of 0. Here, they do not know. Then player A circles one of the 11 answers. All right. Then we would write down with hand that player B receives, and just multiply the answer by $3. And then this information was transferred on a separate decision sheet of player B. So there was no chance of getting any messages, etc. across. And then player B would make their decision whether to return half or 0 back to player A. And then at the end, we would again collect the sheets and calculate the experimental earnings, right, and give it to them.
The belief task isn't there.
That was the first one, right? But I wanted to sort of start with the game. So belief elicitation. Players A were asked to predict the percentage of all players B who will transfer half in the second stage. Right? This was done by answering the following question. I believe that, fill in the blank, percent of players B in the room will return half of the tripled amount. Seamus.
Is it in the simultaneous game only or in the sequential game?
This is in both.
You mean we were just asking about the session of the people in this room?
Oh, just in the room. Just in the room that were there.
Sorry, wouldn't your belief differ according to the 2 rules? I mean, I would think the second one is can these guys read a payoff matrix and come up with a dominant strategy in the simultaneous game? If they can, then I would expect them to return none.
That, and then there's also other issue that I'll just mention. Huh?
Just want to ask a question, maybe a little bit off the wall. Would your sample affect the perceptions that agents or individuals or subjects might have with regards to trust? Because I have no idea how your sample was constructed, where these students came from, their disciplines, their gender.
So they were all undergraduate students. They were randomly selected from the database. So with the database, we have what's it, about over 1,000 people, students, undergraduate students at the moment, from pretty much the whole university, because we posted posters and we went to recruit to all colleges to classes to sign up into the database. We do have information on their gender, on what they're studying, major, etc. However, we didn't use it in the paper because we didn't have any sort of hypothesis about how it should matter at this stage. But it's something we could potentially look at.
They're all students, and you've got all of their records in student web. You ever try just like matching GPA to trust or anything like that?
Not without approval.
Now, yeah.
Well, even just doing it and not reporting it.
Well, Jeremy did, right? You did the grades in math, or was it the behavior? No, what is it? Whether they could solve some problems?
Said that every last student had to agree ahead of time to have their grades released, and if they didn't,
then you couldn't.
So I just asked them to self-reported grade. And
I see.
Broad ranges.
Right. And that was for public good game, right? Yeah.
But I mean, these people can see the other players.
They can see the other players. Yeah.
So I mean, if you're a psychologist, you'd actually suggest that there's something in the way people look or behave, or whether their face is symmetric, or a whole bunch of other things.
They could see them because they were coming all in at the same time. Then we would put them on both sides of the, on either side of the room, and then they were facing the walls, and they didn't know who they were paired with. Okay, so it was anonymous. So it was one out of those 10 or 11.
Let's say you've got 12 with hoodies on.
Yeah.
I was just thinking about the hoodies as well.
Yeah.
Oh, seriously, I mean, con men, if the story's right, I mean, they're snazzy dresses and they try and look smart.
Yeah.
As part of the con. So, I mean, there is something to be said about. May well be that there's, the standard deviation of the players here is low, but the whole other discipline notion of trust that economists wouldn't look at would involve not knowing what they look like, or that would add a dimension to the experiment.
Mm-hmm.
But you probably couldn't see them. We don't the whole.
Yeah, it would change the dimension of it. But what I'm saying is being able to see them.
It's very hard to trust if you don't even know if you can't even believe they're there. Like you think it's.
Well, I think that would be just another version of the experiment. One way you didn't see them, and one way you did.
Now this part of the
Literature, yeah. So in fact, the very, very first study by Bergdekon and McCabe was done double blind. So the people would come. That was done in University of Minnesota, and the subjects, half of the subject sample, for the experiment, would come to one lab on the ground floor, and the other one would come through different entrance to a different floor, so they never met actually. And then they were testing whether there is any trust, etc. There was one that I'm aware of, but they didn't see each other. Then Jim Cox and Kerry Deck, they have another when the experiments were also run from two different campuses. One was Jim was I think in Indiana, and Kerry was in.
But the point
And so,
is, if you're asking the question about them in the room,
right.
you're expecting the players actually in the room to reflect their beliefs. So it must be about some characteristic of what they can see in those people. Otherwise, why would you ask them about the room? You could say, what would you expect students of 25-year-old to do?
Right.
Or something else. So if you're asking them about the players
Here.
That's going to matter only if the interesting question is whether the beliefs of the player depend on whether it's sequential or simultaneous.
Yeah.
And if the more interesting
Yeah. And Also, right, I mean, we wouldn't have a way of actually checking and making it salient if we were asking about the whole population or something like that of the other ones, right? Because over here, what we asked them to do was, well, we told them that their earnings are going to be, right, we just adopted this is Duffenberg and Gnisi 2002 paper with the beliefs elicitation, right? So the earnings depend upon the accuracy, and we endowed all subjects with $5, and for every 1 percentage point deviation from the actual outcome, 10 cents were deducted from the $5. And so deviation of 50% resulted in 0 earnings.
Okay. When you ask them this number, what percentage do you think will return half? What is that going to be a proxy for? Is that a belief about the kind of people who play a beat?
It's going to be a proxy for what is my expectation that the other person is going to do, right? So in theory, it should not matter. Now, one other way of doing that would be to ask, what is the percentage, and what is the chance that the other person that I'm paired with is going to return this? But there's a problem with that. First one, you can't really measure that. What is the percentage, right? I mean, what is the chance that the other person is going to return it? Because you only have, well, he returned or he didn't. And secondly, if you did that, then you could construct a portfolio, right? Because I could influence, especially in the sequential game, I could influence the other guy to behave in a certain way. I mean, if I say there's a 0 chance and I give him t equal to 0, then he's going to give me.
If I believe that trust signaling works, I'm asked how many people in the sequential game are going to return half. I'm giving you information about my belief, not only about what all the player B's are like,
Right.
but about what the player A's are going to do.
Is going to do. That's right.
Means I'm giving you information about what
Yeah.
I believe the other.
That's right. That's right.
What they're going to do. Why not just ask them what proportion will return in the simultaneous game, and then the pure question about what you believe about the category that might be in front.
So do you mean that I would only ask about the beliefs only in the sequential treatment, or I would ask also, sorry, in the simultaneous? And what would I do in the sequential? I would ask also about the simultaneous game as well? I'm afraid it would be too confusing. I don't believe my subjects that much, that they would comprehend the difference between, I give them instructions about sequential and I ask them about simultaneous.
So okay, the people who are playing sequential don't even know about the simultaneous.
About the simultaneous, no.
On the other hand, I guess there's a question of sample size, but presumably if you've got them randomly assigned to 2 treatments, then the responses you get on beliefs from your player A's in the
Simultaneous?
game tells you is a unbiased point estimate
Of what the beliefs of the other ones would have been, yeah. So we have about 37 in simultaneous and 41 in sequential.
Oh, well, multiply your sample size by 200, and that won't be a problem. Les can look after the research committee's next
John.
Hey, Glenn went through 3,000 twice just doing this. Okay, so
Yeah, I know, but Glenn is, he's got more money.
Just a couple of things. If you take that question as given, which I want to question that in a minute, but the scoring, the reward structure we have, I think represents the median, like the optimal thing to do if you're against a mean absolute deviation loss is report your median, against a square deviation loss is to report your mean. If you're sitting there with those kind of loss functions, there's a bunch of standards and theorems which tell you, and there's one for the mode as well. I mean, there's different loss functions. The loss function you have, I think, you would report the median of the distribution of the answer to that question, if someone had such a distribution, whether you want them to be. The other thing is that I think that, in some sense, the binary question is one more salient, and it's also in the solicitation scheme we have. We do the 2 things. We do one it is binary, but you can also construct a portfolio that they would get and what would be the rational thing to do. And it would, yeah, so you got to look at the state.
John, what's the difference between median and mean in this case? If you're asking what percentage of the other people on the other side of the room are going to be giving
Well,
back.
it says, I believe, I mean, you got 20 people on the other side of the room, okay? How many are going to, could be anywhere between 0 and 20? You know, I could think, my distribution is like this, yours is like that, and I'm just thinking that what statistic do I report when I ask
But
this?
it's just what proportion are choosing 1 rather than 0.
Yeah, but I've got to come up with a number.
Yeah.
I've got to come up with a number.
Yeah.
And so the number I come up with is going to be related to my beliefs. And it turns out there's some standard formulas about
Okay,
cost.
so belief distribution really is okay, yes.
Yeah, that's it, yeah. But I think that it's also easier for people to think in those terms of, oh, I'm playing against this guy over here. What are my chances, you know? I mean, well, we don't see that. And it might be, I don't know whether that would be the same in each thing, or as their experience would go along, it would adjust. I mean, in terms of people's ability to comprehend, I think, you know, thinking of, oh, how many people,
How many, yeah.
fraction, largest equal, you know, pick 0.5.
Yeah. Belief elicitation. So this is what actually the first task was, right? We would remind them whether it was sequential or simultaneous, and it was sequential. Right? We would tell them, well, what are you going to answer if player B is going to make the decision knowing how much player A has transferred to them, right? And then in the other one, it was in the simultaneous. It was without knowing. So here's one, or a short discussion on the belief elicitation. So despite the same procedure, right, in sequential treatment, we elicited a point belief, right? Because true belief in the sequential treatment is a function mapping each t into probability of receiving a half. So you actually have a vector, right? Whereas in the other one, the belief is actually a point, the number. Okay, so this is already one thing that when you have to sort of raise your hand. So we decided to ask for just one number to keep the task identical across treatments. Okay, and also because of the simplicity, right? Because just again, the decision cost of asking subjects for 11 numbers could be too high, right? And then we also want to make them decisions about t's, etc. And like I said, I mean, I think there's just so much level of cognitive effort that the subjects are willing to put into experiment, even though if you pay them, right, that just each decision would become less salient, right, over here. Now we're going to assume, right, that the belief that we elicited corresponds to the decision that follows in the sequential treatment, right? However, there's no way for us to check. So subjects' decisions, should I make it on time? In the sequential treatment, we had 41 subject pairs. 21 subjects, that would be 51% of players, sent the whole endowment of t equal to 10. 5 players sent t equal to 0, right? Average beliefs were 51. In the simultaneous, we had 37 pairs. Only 24% players sent their whole endowment. 4 players sent t equal to 0. Average beliefs were 46. Players B returned, and this is just an overall summary, returned the half significantly more frequently in sequential than simultaneous. Right? This is, again, overall statistics. 20 out of 41 and 10 out of 37. And this is statistically significant by Fisher's exact one-sided test for frequencies. So this is really what the summary statistics looks like. In the sequential, the average t, right, was 6.59, and then 21 out of 41 people returned 0. 20 out of 41 returned half. Right. In the other one, in the simultaneous treatment, 5.22 was the average amount sent, and 27 out of 37 subjects sent 0 back, and only 10 out of 37 sent half. So just to check for the self regarding prediction in order to see whether our data is consistent with the previous literature, right? The classical self-regarding prediction would be, just working backwards. Second guy returning 0, therefore first guy sending t equal to 0. We observe 5 such players A in sequential treatment, and 21 players 2 who were consistent with that. And in the simultaneous was 4 and 27. Okay, the subgame perfect equilibrium for self-regarding prediction players does not find much support, especially when it comes to first movers. Seamus.
That 51%, that's including the 5 who are responding to T of 0?
Yeah.
Because
They just could return 0, but they also said 0.
yeah, but that's cheap talk.
Yeah, it is. I mean, it could be you could be also sort of nasty, right, and say, hey, I'll give you half. But
But I mean, it would be interesting just the percentage reported of conditional on having a choice to make what proportion returns.
returns 0. Yeah. Okay. Might do that.
So you're saying even in the simultaneous game, you've got only 4
People, yeah, who send 0.
sending 0.
Yeah.
You know, you should be able to anticipate that the other guy's going to
Should right.
Can't be equal, must be
Okay, so
my game theory course.
so do trust or signal trust, right? So question is whether the mean T conditional on players A's belief is going to be greater in sequential than in simultaneous. Result, yes, this is the case. So we're testing it. We ran a Tobit regression where the restrictions were imposed by the experimental design, right? So it was bounded between 0 and 10. And where is it? The product, so this is the slope coefficient is 1.9, and it's statistically significant. So this is actually P for those is calculated by Stata, and this is for two-sided hypothesis. However, our hypothesis was one-sided, so it actually should be half of this. This is data scatter plot.
Just
Yeah.
the coefficient, so would the size of that coefficient be economically important? Is it big enough to be meaningful, apart from being statistically?
Right, because it I mean it increases the efficiency and the T is higher. So actually, I mean this is a good. Here we just plotted the lines as given by the coefficients, right? So I mean these are not the Tobit lines, but these are the lines given by the coefficients from the Tobit, right? Because I mean Tobit would be curved. So the sequential is statistically significantly steeper. And the question about that I posed at the beginning was about the efficiency, right? We didn't know what was going to be the mass of people that are going to be down here a priori. They're going to have they're going to have low beliefs, right? Mu's close to 0, and hence they're going to send small t's. So that would actually have an effect of whether we would have a significant intersect here or not. Jeremy?
You elicited beliefs before the game?
Before the game, yeah.
I guess there's good reasons for that, the board's rationalizing
Yeah.
such behavior.
Yeah.
On the other hand, that means they were having to answer beliefs about a game that they haven't actually played yet. I feel pretty sure that they really understood what the game was, even though they haven't done it yet.
Yes, I mean we went to great length to explaining that this is a sequential nature of the game and this is simultaneous. So again, I have usually small confidence when it comes to subjects, but and in particular certain things that we find really important we try to explain, right? So we would go to great lengths and ask them to ask us questions where there was something that was unclear. And I think we reiterated the fact that it's sequential and that it's simultaneous about 5 or 6 times even.
How come the y-axis stops at 1 instead of 0?
Tucker.
I want to know if the ones that gave nothing, whether the beliefs were all on 0 or whether they thought it was just.
I have no idea.
Make it worthwhile.
I have absolutely no idea.
Well,
I didn't even notice that it was there.
yeah, I mean, I think scatter plot is very, very informative. I think the regression lines are very uninformative. I mean, there's clearly something going on with all the people are giving 10. I mean, there's just an enormous spread in their beliefs, which doesn't seem to be quite so characteristic about.
Believing 0 and giving 10. Some idiot believed 0 and gave 10. Can you beat them after the experiment?
I think that,
They
yeah,
may not be an idiot, they just be a nice person.
yeah, it could be an altruist, right?
What I said.
This may be your future wife, okay?
Could be an altruist, actually. In fact, this was, yes, this was, I'm going to blame it on Steve. Steve was the one who said, like, oh, this guy, in fact, exactly what he said. This guy is an idiot. And so we were thinking about it, it's like, we should eliminate it.
Steve, would you say that?
No. And then we realized, well, he might not be an idiot because he might just be an altruistic guy. Right? And so there might be, there, in the distribution, no, we didn't throw him out. Yeah.
I still think it's very interesting if you look at the amount invested at 2, and then you read across horizontally. If you were to look at the beliefs under sequential and the beliefs under simultaneous, you know, I mean, again, it's a stochastic dominance kind of thing, but definitely the sequential guys are lower at that level, and yet up in the.
So these would be the ones, right, that have lower beliefs.
They're lower beliefs.
And so they give less, right?
Yeah, no, that's fine. I'm just saying at that level, there's a bit of dispersion, and the distribution of beliefs for the sequential game is to the left, which sort of like beliefs in the whole are kind of smaller for people to give, which is consistent with what I would believe. And then I was just thinking, if you looked across the row at the top,
Huge.
It's all over the place.
I mean, those stochastic dominance comparisons in these distributions can be quite. I mean, just a little scatter plot can be quite helpful for the conditional in the amount that they're giving. You probably only got 2 where there's enough observations, but because it's kind of reversed at about 5. I mean, at 5, well, it's just that one guy.
Yeah.
Well, actually, yeah, you don't have really enough observations. I don't know.
I'll probably come to your office for the stochastic dominance. The lines by Tobit. Oh no, the lines. The lines we just you took the data and we plotted them using these coefficients. So whatever we estimated from Tobit, and just made the lines. Yes. Yeah.
You didn't consider doing this count data?
No. No, because we all suck in doing these type of things. We just did the simple lines. That's an honest answer.
Just going back to John's, before you even get beliefs, it'd be quite nice just to see the distribution of T's plotted as cumulative distributions.
Mm-hmm.
That would be one thing, just to see if it competes against the dominance going from sequential.
That's what I thought it should do rather than test means.
Okay.
Yes, plot distributions, because there's a lot of information
In.
inside the beliefs.
Mm-hmm.
Also look at the distribution conditional on being greater than 0. Say conditional on not giving. So what happens to the proportion giving 0?
Giving 0, yeah. I'll do that analysis for the I'll do the analysis for the payoffs greater than 0. Maros.
It also seems that the huge scatter that you have over there suggests different personality types. So you have, with regards to beliefs and
Right.
trust and all that. So you have different types of individuals, and you have
Within these.
this huge spread, this huge array with regards to, especially with the sequential gauge right on top.
Right.
It might be.
Over this
We
thing.
don't have homogeneous individuals. We have heterogeneous individuals with perhaps heterogeneous preferences with regards to
Yeah.
trust, which also doesn't fit
Yeah,
necessarily
yeah,
with the standard literature. I think the scatter should be interesting.
Mhm. It kind of made us happy, right? Because at some point we were not, well, we weren't sure whether we wanted to do the Duffenberg and Gnisi type of belief elicitation, right? Because the criticism would be that it's pretty flat and people just should report the mean, but then the sort of viable scatter was like, well, you know, it doesn't apply. Jeremy, you had a question, or?
I did, but
Oh.
John actually did.
No, go ahead, Jeremy. I'm still thinking about this.
I was just going to say, before you try and get your head around stochastic dominance, a cheap and easy thing to do is, along with comparing means, just comparing variances, that there would be very test comparing variances.
Yeah, okay.
Just before you leave that, again, I was looking at the graph horizontally, but if you look at it vertically, if you take the, because that's the way, in some sense, for your hypothesis 1, you should.
Right.
It's conditional on a belief.
Uh-huh. What is
levels
the,
you're given?
yeah.
So if you compare 80, at the level of belief 80, and if you go up vertically, you've got quite a wide range of simultaneous, and then the sequential.
Down and the sequentials are at the top.
On the top. But then if you go over to 20,
Right?
and at 20 it's, it's more.
Right over here, yeah.
Well, yeah, vertically up from 20, there's one right on the axis, which is simultaneous. There's a bigger spread in the simultaneous, sequential is kind of tucked in there, but I would think on average it might be reversed. I don't know. It's just that conditional. I mean, you could look at your hypothesis one, sort of, rather than use the regression thing, just looking at vertical slices across that graph and comparing the two treatments. I mean, when it's possible to compare them.
So, could those guys along the top be gamblers?
Yeah.
If it's a cold, frosty night, you've gone out the experiment, and you know that these people aren't going to give you any money back, but hey, you're going to walk out with $10 and it's been a waste of your night. If you walk out with $10, you might as well roll the dice.
And go for 15.
And hope that you're going to walk out with 30.
That doesn't
15.
look like a simultaneous game.
It could, but that'd be with 15, right? They'll just walk out with 15. So I don't know. It depends on.
There could just be some tipping point between those two figures where it's worthwhile.
Could be two. Could be that's.
Let's go back to regression. Presumably one side of October 10th at 0.
Yes, 0 and 10.
Oh, it was 0 and 10. I was
Yeah.
going to say, I presume Tucker left out 0 there because it was part of the centering. But
Oh, yeah.
10, so, okay, we'll beat Tucker up next
Yeah, okay. Please do. Tim.
I'm just wondering how this whole diagram would change. I don't know if it's a very good time to ask the question, but your whole game was based on the fact that if someone gave the money back, like that they gave the half back, then they actually lost out. A lot of the guild aversion games that I've read, you actually can earn some money when you give that back, but there's this free rider problem where if you give some of the money back, but you choose to give half back, you might actually receive more money as well. And it seems that there'll be a completely different level of trust for, like, let's say in a marriage or something, you're like, I trust you to do this when that person wants to do that thing. And then a completely different level of trust when I trust you to do that, you don't actually want to do
Yeah,
that.
so in a sense, you're talking more of like coordination games,
Yeah, well,
right? Where
if you compare this to other literature around them, it's quite different in terms of the level
Could
of
be.
trust and then how that affects the sequential game as well. If you
It's good.
compare back and if you gave that money back, that you had a chance of giving that money back, and then I don't know, there's a flip of a coin, and you might actually give that money back, but it's then given back to you, and it's given to both players, and everyone wins from that situation. It's
Right.
quite a different game, and that's
It
what
is. Did in the other one, yeah. I'm just gonna probably speed up a little bit because I'm almost out of time. So, so whether the trusters benefit, right? So the question was whether there's an increasing relationship between T and frequency of fair split made by players B, and this is where we were just shocked. So players B only reward highest signals of trust, and so this is what we are observing here. So this are the level of T. So this is for the sequential. This is how many players or how many instances there were of people giving 0, 1 through 10, right? And the solid line or the black one represents players B returning half, right? So notice that the only person who returned half was over here when it was below 10, whereas all the other ones were only for where the player number one sent the whole endowment, right? So in the sequential treatment, given that player A invested T equal to 10, 91% of players returned half. Whereas given that the player A invested anything less than 10, only 1%, only one person returned half. So we reject this hypothesis, right, that an increase in T induced a higher frequency of half for all levels of T.
But it's still a really interesting finding that if you give it all, it creates a great
it's great, yeah.
So it's common knowledge.
Right. So in a sense, right, it's more like if I send anything less than 10 is a signal of distrust. Although I don't like interpreting the results right afterwards of the experiment, but yeah, it's all or none. I like this graph, right? So I mean, it's the same thing. It just looks the frequency of returning half for a given T in the sequential. So the question whether trusters benefit by sending T equal to 10 in sequential, right? So average ACE earnings overall in the sequential treatment were 10.44. If you would send everything, then the average earning was 13.60. If you'd send anything between 0 and 10, right, you'd get 620. It excludes 0, right? Because I mean, if you send 0, then your earning is going to be 10. So, but now the question is, right, are these guy is better off by sending everything in sequential than in simultaneous. Right? Now we cannot make a direct comparison because in the simultaneous treatment, players B do not observe T, right? So therefore, we just compare it with the whole population. And the average players A's earnings are 690. Okay? So the player A's are doing much, much better in the sequential treatment. So does the strategic use of trust improve efficiency, right? So in a sequential treatment, if mu is high, it is optimal to send high T, right? But if it's low, then it is optimal to send 0, right? So the question was, it was ambiguous. And we're testing this now. And virtually what we're doing, we're comparing the average T's, right? And the T is statistically significantly higher in the sequential treatment than in simultaneous. And this is also true when you're looking at the proportions of people who send the whole endowment in sequential versus in simultaneous. Right? So just a short discussion on the implications of evolutions, right? I mean, and this is just, we're just speculating. We didn't design the experiment in order to test this, but many institutions appear to have a sequential structure, right, that allows for trust signals to be visible, sometimes even for public display of trust. And sometimes there's no obvious reason why it should be that way, right? For example, in internet trading, right, the way, the sort of standard way of making a trade is that the buyer first sends payment, and only after it clears, then the seller sends the product back to the buyer. It'd be way more efficient if this was done simultaneously. Okay, so again, but we're just speculating. This could be one of the reasons. So I'm just going to skip that. Some disclaimers. The behavior in our game, those are only proxies, right, for trusting and trustworthy behavior. There could be other motivations present. Thus, the results should be interpreted with cautions. And also, these results might vary with the different strategic and contextual environments, right? The fact that we are in the lab observing these subjects might cause them to behave differently, etc. So, our future research, what we are working on. How this trust signaling works, right? Is it perhaps via psychological forward induction? That is, do subjects, the second players, really update their beliefs about what the trust is and respond accordingly? In order to do that, we need a simpler game, right? Probably just binary for both of the players, and then we can measure the belief before player A makes his move to invest, and then afterwards, and in order to measure whether the beliefs go up. And then the next question is, how does this trust signaling translate into less stylized environment than in the lab? I'm not going to go through a theoretical example that I have. We can read it. It's in the appendix. Morris.
After Greek, Stanford has written a lot in terms of economic history and this evolution of institutions and trust. And that might put in context some of the experiments that you're doing here.
Excellent.
He looks at medieval institutions.
Somebody just
Grief.
explore the hell out of the
I think so. Yeah. Excellent. Thank you. I wish I talked to you about it when we were writing it, because we were looking for these examples, and for a moment we wanted to pitch it in as an evolution of institutions, but then the design wasn't quite like that. Seamus.
With H3, and the same thing has been backing me all along. The statement that mu is high and sequential. It's optimal to make T high when mu is high and T low when mu is low.
Yeah.
But I'm not convinced at all that beliefs about what proportion are going to send back half, when whether they send back half is going to be conditional on what they observe, and you don't know what they need to do. I'm not sure there's any prediction under any theory of what the relationship between the belief about what people will do that is itself going to be conditional on something that I'll ask about the belief side would have on T. So you could get anything there that would be consistent, I would have thought, with any story. For the reason you said, it was too difficult to ask.
For the question, so, what it is. There's lots of interesting stuff there. I just don't think H3 is an interesting hypothesis because it's just too difficult to characterize beliefs in a way About what it is.
For the simultaneous, for the sequential game. Have to think about it.
To ask, for the question, what it is.
For the sequential game.
Have to think about it, what you said. You might be potentially right. Okay. Well, thank you very much for the comments. This was probably the most questions I've ever got on this paper, but very appreciated.
All right, well, could you join me in thanking Maros for a very interesting
Thank you.